Afternoon, everyone. I am Kyle Hankinson with KCH Engineered Systems, joined by my colleague Arlene Miller with HEIL out in the Southwest. I'm here in North Carolina working out of our office, and Arlene's out in the Southwest in Arizona area. Welcome to our first wet scrubber maintenance webinar. This is the first webinar in a series of quarterly information that we're going to be putting out to a lot of our customers and prospective customers, all about how to maintain wet scrubber systems, and then future probably get into the design applications more heavily on wet scrubbers and other air pollution control technologies. We hope this will be a very informative, and you'll find value out of this webinar. This is really designed for maintenance teams, facilities engineers, and others that can maybe give you a few extra things in your toolkit to help troubleshoot any issues that may crop up. Give you a little bit of background on our companies. ECS, KCH, and HEIL is now a family of environmental technologies. Our three companies combined forces back in 2019 to become essentially the largest provider of odor and air pollution control systems in the U.S. now. We have around 100 to 120 personnel on our teams spread throughout the United States, and we also have in-house design engineers and manufacturing facilities in both Texas and North Carolina. Texas facility at ECS has an extensive array of equipment and composite fabrication and fiberglass, around 100,000 square foot of facility and winding equipment and others in that facility. And our North Carolina facility here at KCH focuses mainly on thermoplastics fabrication, polypropylene, PVC, polyethylene, some dual laminates, and others. Both facilities also have NSF certification for some drinking water components in our industry. Again, I'm Kyle Hankinson, joined by Arlene. Just give you a little bit of background on your speakers today. Arlene is a degreed chemical engineer, started off at HEIL back in the 1990s as an applications engineer, and eventually worked into becoming the general manager of HEIL through the years, and recently moved to the Southwest United States to take a position for our enterprise of companies to head up our aftermarket sales and services. Again, I've with KCH out of North Carolina here, and travel extensively throughout the United States, visiting metal finishing facilities, chemical production facilities, and others, treatment facilities on the waste and drinking water side at municipalities, and have a fair amount of field experience and sales in our industry. Spent a little time in the military as well. So just a little bit on the agenda. We're going to try to keep this to about a 35 minute presentation. We're going to first cover the principles of operation, and then Arlene will handle that. Then I'll get into the operation and maintenance issues. I'll show some examples of some issues that we see that are common. And then I'll hand it back off to Arlene, and she'll get into predictive maintenance and monitoring, how to prevent maintenance issues and downtime in the future. Then we'll follow up by a Q&A, and hopefully keep this whole thing around 45 minutes for you. We do appreciate you taking the time out of this week to join us. A little housekeeping, so everyone is muted, so we won't be able to hear you. This is mainly to reduce the background noise. And so if you have any questions, feel free to use the Q&A tab within the webinar, or certainly afterwards you can email us as well. We'll have our contact information for you. This session is also recorded, so we'll make sure we get a link out to all attendees. Link will probably come within a day or so after this, because we'll cut out the kind of the intro section, give you the meat of the presentation. All right, I'll go ahead and hand it off to Arlene. She'll cover the principles of operation.
Perfect. Thanks, Kyle, and good afternoon, everyone. While ECS, KCH, and HEIL offer a wide variety of wet scrubbers, such as our Venturi particulate removal scrubbers, our wet water jet induced draft scrubbers, and our sip tray scrubbers, today I only want to briefly cover the operations of our wet pack bed scrubbers and mist eliminators. So wet pack bed scrubbers are designed to remove gaseous contaminants via mass transfer and absorb those contaminants into either a recirculated chemical solution or freshwater liquid stream. At ECS, KCH, and HEIL, we have two types of wet pack bed scrubbers available. So the first type that I want to discuss is our vertical counter current flow units, as you can see here in the photo. For these units, the dirty or contaminated gas stream is brought in towards the bottom of the unit. The gas stream travels upward through the wet pack bed section, and by the time the gas stream reaches the top of the vessel, the gaseous contaminant has been removed from the gas stream, allowing it to either be discharged to atmosphere or continue on for further processing. Simultaneously, the recirculated chemical stream or fresh water stream enters the scrubber towards the top of the unit, travels down towards the sump of the unit, contacting the gas stream in the pack bed section, absorbing the contaminant and allowing the contaminant to be collected or discharged from the sump of the unit. Hence, we get the term countercurrent flow. Additionally, the scrubber is provided with an entrainment separator, whether it's in the form of packing, chevron blades, or a mesh pad assembly, to capture any entrained liquid droplets in the gas stream prior to discharging from the unit. Moving on, the next type of wet pack bed scrubber, there's a horizontal cross flow units, again, as seen in the photo here. While this is very similar in the principle of operation to the vertical countercurrent, the gas stream enters the scrubber on the left-hand side of this pictured unit and travels horizontally to the right side of the unit, while simultaneously the recirculated chemical stream or fresh water stream enters the scrubber towards the top of the unit and then travels down towards the sump of the unit, contacting the gas stream again in the pack bed section, absorbing the contaminant and allowing it to be collected or discharged from the sump. Again, hence we've got the term cross flow. Again, just like the vertical unit, the scrubber is provided with an entrainment separator, whether it's in the form of packing, chevrons, or mesh pad assembly, again, to capture the entrained liquid droplet in the gas stream prior to discharging from the unit. So next we have our mist eliminator units. These units typically utilize mesh pad assembly and they operate dry, excuse me, as to remove the entrained droplets via inertial impaction, direct impingement, and Brownian motion. In addition, these units can also operate wet using either manual or automated periodic spray washdown cycles to help clean the mesh pads. These mist eliminators are typically designed for 10 micron and larger removal efficiency, but we can go as low as 1 micron in certain applications. Unlike the pack bed scrubbers mentioned earlier, the mist eliminators cannot absorb gaseous contaminants, and neither the pack bed scrubbers nor the mist eliminator units are designed to remove submicron particles. So what components are found inside a wet pack bed scrubber? The good news is that a wet pack bed scrubber, unlike a fan or a recirculation pump, does not have any moving parts in it whatsoever. Internally, you're going to find the packing media, the packing support plate, liquid distributors, and entrainment separators. Exterior to the scrubber are recirculation pump or pumps, recirculation piping, system instrumentation. In addition to these items, we can also provide additional system components such as hoods, plenums, inlet ductwork, dampers, system fans, pre-control filters, and system controls. So this leads everyone to ask, why am I having issues with maintaining my wet pack bed scrubber? Our experience has shown that design flaws typically lead to increased maintenance issues. These design flaws are typically related to modifications or additions to the process exhaust stream or changes to operations, such as decreased water supply or increased chemical addition. Adding additional exhaust streams to an existing system can also lead to improper velocity profiles in the scrubber, undersized recirculation pumps, or poor air distribution at the inlet or outlet of the scrubber. Modifying the chemical feed system and locating the pH probe right after the chemical addition location could provide a false reading as to what is actually in the recirculated stream. But not having sufficient chemicals in that also maintains your system contaminant removal efficiency. Adding other processes or tank ventilation to your existing scrubber could also lead to lower exhaust of the original process system, which could put operators and equipment at risk of exposure to harmful corrosive chemicals. In addition, reduced pack bed depths or a fouled spray nozzle are another common issue. So now I'd like to turn it back over to Kyle to review some of the operation and maintenance issues.
All right, thanks, Arlene, for covering all that. Some of the common things we see crop up in maintenance issues often start in the recirculation of the wet pack bed system. So this particular case, you have the packing media that's just randomly dumped inside the pack vessel, and so you can see a pigtail nozzle on the left. We often use different types of nozzles. Most all are open cone type to provide good coverage. But here you have a situation where there's not enough packing depth that was provided, maybe due to settling from shipping or whatever. Could have had some packing pulled out of the system, and so you get nice, good, clean coverage in the center section of the wet scrubber. But then you can see on the walls, on these back walls, you're not getting very much scrubbing liquid coverage at all. And you can see the packing is getting really dirty on the outer walls along there. And so it's important to keep this packing media clean. And in doing so, you typically need to add a certain amount of fresh water based on evaporation, maybe in your location, and have a continuous amount of blow down that occurs to go to wastewater treatment. If you don't have that, you get a constant buildup of contaminants inside these wet scrubbers that will ultimately lead to a fouled packing type situation. And when you get really fouled packing, you're getting reduced airflow, you're getting increased pressure drop, and overall low airflow at the process may lead to some safety concerns about capturing the contaminants at the process. So it's important to keep these things clean. And the worse off they get, the harder it is to remove any kind of contaminant that's built up on these. Sometimes you can perform an acid wash or some type of internal wash of the system, but sometimes you just have to completely replace the packing media. And if these systems are operated properly, the packing media can last 20 or more years without having to be replaced. If they're not operated properly, it may be a year or two where you need to replace the media in the system. So the spray nozzles, in this particular case, we have a horizontal cross flow scrubber where the contaminated air is entering from the left side of the pitcher and moving towards the right. And we have a series of open cone style nozzles. I believe these are 5 PSI nozzles and 5 GPM. This system has been operating for only 60 days, brand new, and is getting a major salt crystal formation that's occurring. And this is essentially due to insufficient fresh water. So this customer was adding caustic when the pH would drop. When you have that acid airstream coming in, you're trying to neutralize with caustic, but they didn't have enough fresh water going into the system, and you get this precipitation reaction causing all this crystallization. You can't even see the main manifold of the spray header anymore here. And so this is a major problem that can be rectified fairly and could have been prevented fairly easily if there's enough fresh water going into the system. And ultimately, this will build up further to the right in the packing section of the wet scrubber if it continues. The mist eliminator section, typically on the outlet of the wet scrubber, can either have a composite mesh pad or a vane style mist eliminator, like a chevron style mist eliminator. The vane type mist eliminators can handle and remove water droplets down to the 10 to 20 micron size diameter with about 99% efficiency, whereas these composite mesh pad mist eliminators can remove droplets down to around 1 micron size particles. And so, depending upon the application, we'll choose the mist eliminator accordingly. One issue that we see a lot in composite mesh pads is that they'll get built up, they'll clog much more easy than a chevron vane style mist eliminator. And so in this case, you have a surface buildup that's beginning on the pad, and then it's worked its way into the cross section of the pad, ultimately causing that pad to plug, increasing the pressure drop across that mesh pad and reducing overall airflow in that scrubber system. This style of pad is more of a random weave mesh, and we've also used other style pads, which in the lower left corner here picture has a structured three-dimensional grid that actually it comes in layers that are more easily pulled apart and cleaned. So depending on the pad type you use and the configuration, you can oftentimes pull that pad apart, clean it with a hot water pressure washer in a contained area or a warm water pressure washer, and reuse that pad in the future. Pumps are a critical part of a wet scrubber system to keep that recirculation moving, and all pumps require some level of maintenance, depending on what type of pump it is, either vertical centrifugal or a horizontal centrifugal or a mag drive pump. And we select pumps based on the configuration, oftentimes, of the way the scrubber is configured. If we have a self-contained sump on it, or a remote sump, or if the scrubber is mounted outdoor on the roof, or or in a basin somewhere. This case, we have a horizontal centrifugal pump that was provided, and one issue that we see here is that this pump seal requires water for lubrication, or really to keep the seal cool. And this application, the plumbing company accidentally plumbed the process water into this pump seal, mechanical seal location, and that process water contained some corrosive chemicals. So it should have had fresh water piped to it, which would have really helped that seal out. And but in this case, we had a pump issue that caused a premature failure of mechanical seal. So it's important to plumb these things up properly with the right type of solution, as well as just lubricate and maintain in accordance with that pump maintenance O&M manual. These things have bearings and things that nature that could be lubricated as well. Another kind of a nasty issue that occurs is blockage in a drain system on a wet scrubber that can ultimately lead to bypass and ingestion of a chemical into the fan. What happened, which is what occurred here in this picture. This is a chromic acid solution that was operating on a dry composite mesh pad system that also had a wet section along with it prior to the MAC standard, which moved all compliance to a dry mesh type system. But they had a rag get ingested into a inspection port, and then that rag worked its way down to the drain and clogged that drain piping. All the while, you have fresh water going into this system to try to keep those mesh pads clean. Well, that fresh water mixing with that chromic acid build up, and the sump level raised to a point to where the mesh pads were bypassed, and that chromic acid was sucked in to the fan and just causing this nasty situation to occur, which ultimately can lead to some stormwater drain issues down the road and a lot of environmental type problems. So it's important to keep that plumbing inspected, maintained, and again, a lot of times what we see is sometimes from the get-go, the plumbing is not properly routed or installed, which can cause some maintenance issues in the beginning. All wet scrubbers have some level of instrumentation, and some of the most common instruments found on scrubbers are the pH probes and ORP probes. pH probes obviously used for neutralization. In this case, we have a very contaminated sump and an iron deposit that's been built up on this pH probe shaft here, and then the inset picture has some buildup on the actual glass electrode of the probe. Those electrodes are very sensitive. They contain a salt bridge within them and require a very frequent calibration. Typically monthly is what we recommend, with buffer solutions of 4, 7, and 10 pH. Those probes, if that sump and that scrubber is just not maintained with good fresh water and a good blowdown, then those probes can start to get built up on them. You can also have some other issues that crop up with pH probes. We've seen ground fault issues, especially in situations where a VFD-driven fan, a fan that's operated by a variable frequency drive, is in the area and causing a little bit of resonant noise and stray current if that sump is not grounded properly, because of those very sensitive electronics in those pH probes. So a couple things there you can troubleshoot. A lot of times, depending on the type of probe you have, if you have an issue that you can't resolve, then you either have to replace the entire probe or some manufacturers have a situation or a setup where you can replace only the salt bridge. But we only recommend that for folks that are very experienced in pH probe knowledge and essentially have some chemistry background. Another piece of instrumentation that's very commonly found and important on a wet scrubber is that differential pressure gauge, whether it be a magnehelic gauge or a indicating gauge. You can have analog or digital. We often use Dwyer, or sometimes we'll often use Rosemont as well. And so it's important to keep those tube connections, that tubing that goes from the inlet and outlet of the scrubber to that gauge, keep them free of condensate buildup. A lot of times that's one of the issues that we see is that there's no condensate trap that was installed on that magnehelic gauge, and just enough will clog that pressure reading and cause that magnehelic gauge to read erroneously. So it's good to have condensate traps with little drain valves on them that you periodically go and check to keep the condensate out of it. A lot of times trending that pH information, or sorry, that differential pressure information will allow you to make a determination if you need to go investigate a pressure drop situation. We recommend not only monitoring the differential pressure on the pack section, but also that composite mesh pad outlet section of a scrubber, which is more prone to plugging than the pack section. Exhaust fans and blowers are a part of the system, a very critical part that need to be maintained. Some common issues that we see in the field revolve around belt tension maintenance, sheave alignment, where these sheaves aren't aligned, or bearing temperature, vibration, wheel vibration. Those are really some of the most common issues that we see with fans in the field. So it's important to keep a regular maintenance on these fans. Each bearing manufacturer has their own recommended lubrication guidelines, and it can be a bad thing to over lubricate a bearing. So sometimes too much lubrication can be a bad thing for a set of bearings, depending on that style. So certainly follow the directions of that particular manufacturer. Also, it's important to make sure these sheaves are lined up. If they're not lined up properly in alignment with each other, then they can cause excessive tension and wear on those belts and premature failure. Fans, this particular fan is a HEIL fan with a stainless steel base and a fiberglass housing and a fiberglass wheel on the inside. It's important to keep buildup off of these wheels. So there's an inspection port on the back side of this particular fan housing that allows you to go in and take a flashlight, periodically check that wheel for buildup. If you start to notice some vibration on that fan, then that's the first place we typically would go, is to look for buildup on that wheel. Maybe you're operating the system and there's some bypass getting through the scrubber, or you're salting out in the scrubber and you're getting salt formation buildup on that wheel, causing it to come out of balance. And it's a maintenance activity. Go in and you can clean that wheel up, and oftentimes it will take care of that out of balance situation. If you don't keep these things in balance, then you can have catastrophic failures. This example is a catastrophic failure of a backward inclined centrifugal exhaust blower wheel. The situation got out of hand with excessive vibration that went unchecked, and essentially had a wheel moving at a very large RPM, probably in the 2,000 to 3,000 RPM, begin to fly apart and shoot shrapnel. through the fan housing here on the left. Very dangerous situation. You know, if there's personnel in that area, it could cause injury, serious injury. And so it's just best to keep these things in check by monitoring. We'll get into monitoring a little bit further here soon to prevent a catastrophic failure of these fan wheels and shafts. So aftermarket, we have an aftermarket side of our business that Arlene Miller heads up along with her assistant Rachel Holm, and that's basically designed to keep you stocked up with parts, service, and repairs. We can help you from a manufacturer's standpoint, come out and do a quarterly preventive maintenance on your system, go in, inspect it head to toe, and provide you a nice report from the manufacturer. That's a service that we provide. And often that report is a nice handy little thing to hand off to an inspector that might be coming to visit you. Kind of puts the onus on the manufacturer in keeping that system clean. So that's something we can offer. And then certainly we recommend replacement parts to keep on hand. The critical parts to keep on hand are oftentimes pH probes, an extra pump, maybe an extra fan wheel and shaft, and composite mesh pads, and some others, fan bearings, gaskets, spray nozzles, access doors, and possibly some packing media. As you can see here, the lead time on some of these some items at the top there are 4 or more week lead time, so it'd be very good to keep those on hand so that in case something really fails in a major way, you can pull it right off the shelf. And then things that are typically quicker are those spray nozzles and bearings. We do highly recommend, though, keeping an extra set of fan bearings on your shelf, prevent a downtime, reduce downtime. All right, we'll go ahead and hand it back to Arlene to cover our predictive maintenance and monitoring.
Thanks again, Kyle. While Kyle covered some of the operation maintenance or preventative maintenance issues, I'd like to discuss some predictive maintenance issues. This may be a new term to a lot of folks, but you're going to find it's very beneficial for the technicians, operators, maintenance, and plant managers. With ECS, KCH, and HEIL's Insight service, timely and proactive troubleshooting will spare companies costly downtime on predictive maintenance. This allows system operators to see real-time operation, along with predicting or forecasting upcoming operating issues. So here you can see a screenshot of an actual system display for an ECS Insight system on a mobile phone. The next slide shows you a photo of an ECS system with an Insight system installed in the field. Here you can see in the photo on the left-hand side, just to the left-hand side of the push-button remote control panel. So our Insight system enables us to monitor such variables as pH, temperature, recirculation flow rate, and liquid levels, as to be able to be proactive in addressing failing parts or malfunctioning system operation before that system is completely shut down for an unplanned disruption or an unscheduled shutdown. So why do you want to be proactive? The Insight Predictive Maintenance System affords you the opportunity to capture not only real-time operation, but also capture and trend the operating data, servicing and planning a successful scheduled maintenance at a convenient time just to replace the minimal parts needed, drastically reducing the severity of equipment damage or outage downtime. And I've got a great example of this coming up in a moment. Eliminating access time to inaccessible parts during an unplanned shutdown. Investing or protecting the equipment to have a longer life, along with meeting your system's environmental compliance needs. But most importantly, reducing your overall downtime by as much as 90%. I'm sure that we've all heard that old adage, if it ain't broke, don't fix it. But our next slide really proves this wrong. Here we have an actual customer example in which they ignored their fan vibration issue just one too many times, only to have the inboard bearing, you can see there on the right-hand side, catastrophically fail and ultimately tore apart, damaging not only that bearing, but it also damaged the shaft, the fan's drive, impeller, and the fan housing. So typically, the cost to replace a set of bearings is usually around $500. In this example, not replacing the bearings in timely fashion cost approximately $50,000 for just the new fan. That price didn't even include the removal of the old fan, installation of the new fan, and the biggest ticket item, the revenue lost by the customer who was not able to operate this specific process line until that new fan arrived. So when you look at the bottom line, it certainly pays to be proactive, or in our case, it pays to have our insight system. So this takes us to the end of our wet scrubber maintenance webinar presentation. We have been very fortunate to have such a great turnout for our first webinar. All of us here at ECS, KCH, and HEIL would like to thank you for all your continued business. And should you have any questions regarding information presented today in this webinar, or if you should have any questions on how you can get replacement parts, services, insight system for any of your ECS, KCH, and HEIL products, please feel free to either contact myself or Kyle at the phone numbers and the emails shown on the screen right now. So now we'd like to open up this portion of the webinar to any questions anyone may have.
Thanks a lot, Arlene. And just keep in mind, if you do have any questions, you can type them in. We have one question. I'll go ahead and take it. It's how secure is the Insight monitoring system? This ECS Insight monitoring system that we now use at KCH and HEIL as well has different levels of security based on that customer's need. And so we can have a base level and a more advanced level and then a really high-end encryption type security level. So it really just depends on your need and your application. And also, this system has the ability to tie into either a wireless Wi-Fi type connection, a hard line, Ethernet connection, or in remote locations, we can tie into a cellular network as well. I have another question. Can you add Insight monitoring to an existing system? Yes, you can. You can take outputs from instrumentation. These Insight boxes can they're like a bolt-on type configuration where it's a NEMA 4X, environmental enclosure that can be mounted outdoors in the vicinity of a scrubber, and you can tie in multiple inputs from instrumentation on the scrubber, or maybe it's bearing temperature monitors on the fans or vibration monitors on the fans, and add them tied into the existing system. You'll need the wiring run conduit and wiring. Otherwise, the box should come pretty much pre-configured with very little additional configuration needed there. Will you be sending out the presentation? Yes, we'll certainly be sending that presentation out shortly. And can the Insight monitoring system be used to change operating parameters of the system in addition to monitoring? And so that really depends on what level of control you want to give an outside party. We can take control and make changes. Some folks get a little nervous about allowing an outside party to control a system, but that can be configured into the Insight system. You can also have the ability to control it yourself remotely to a certain extent. And I think that was pretty much it for the questions. So thank you all again for your time, and we will get the recording out and the link out to everyone here within the next day or so. And have a wonderful afternoon. And thank you again, Arlene.
Thank you.
Take care.